Grade 11 Pre-Cal, Lesson 21, Solving Quadratic Equations by Factoring. So now that you have a good grasp of factoring, now what we're going to do is we're going to solve for them. I mean, example here says find the roots, right? So you're looking for x-intercepts or zeros. There's multiple names. So basically you have your trinomial here. You're going to factor it and then set it equal to 0, right? That's the main component of it. So take this guy. So the best way to look at this is actually go through an example. So here it is, x squared plus 5x plus 4, right? The positive in front of the 4 means the signs are the same. Over here, they're both going to be positive. Factors of 4, 1 and 4. Added together, yeah, that gives us 5. So here is our factored trinomial. It's equal to 0. So all we do is we take each binomial and set it equal to 0 and solve. And that's what we're looking for. That's our answer. So we have x plus 1 equals 0. Rearrange that. X equals negative 1. That's one of your answers. X plus 4 equals 0. Move the 4 over. X equals negative 4. That's your other answer. Okay, it's as simple as that. And the key thing is you have to be really good at factoring for this to work. If you struggle with it, you're going to have to go back and review that. Okay, next page. So here, again, factor each of the following expressions completely. Now this one doesn't say solve, this one just says factor. So again, it's more factoring again. GCF, take out the 2. We end up with x squared minus x minus 6. Factor this into its two binomials. The negative in front of the 6 means the signs are different. Factors of 6 are 2 and 3, right? So x times negative 3 is negative 3x. Positive 2 times x is positive 2x, and that gives us our negative x here. Now, what if you get something like this, and you're going to get these later on, is you have sine. Well, we know already we can replace things we don't know with things we do know. So let's sine theta equal x. So, okay, I'm taking out the sine theta. I'm just going to replace it with an x. So 2x squared plus 3x minus 2. Now, that looks familiar. You can do that, right? The negative in front of the 2 means the signs are different. So factors of 2x squared are 2x and x. Factors of 2 are 1 and 2, and we just don't know the order. It could be a 2 here. It could be a 1 here. But you do your FOIL, and you figure out, yeah, that's where we get our 3x from, because 2x times 2 is the 4. The negative 1 times the x is negative 1. We get our 3x. And then when you're done, make sure you do this. Since you substituted x in, you got to put the sign back in. So you end up with 2 sine equals 0, sine theta plus 2. Sine theta plus 2. And then you can make these things equal to 0 and solve for them. That's the next step, is the solving part. Okay, so let's do example number 3 actually does that for us. So here it is. Here's our stuff. 2x squared plus x minus 1. Right? All we did was replace the the sine theta with an x. And there it is. 2x minus 1, x plus 1 equals 0. Put the sign back in. So wherever the x was, we replace it with sine theta minus 1, sine theta plus 0, plus 1 equals 0. Then, because they're both equal to 0, we solve for both of them. So first, left side, 2 sine theta minus 1 equals 0. Move the 1 to the other side, divide by 2. Sine theta equals a half. The right-hand side over here, sine theta plus 1 equals 0. Sine theta equals negative 1. Okay, now we can do our solving. And while we're here, let's look at this one. Sine theta equals negative 1. You can just look at your unit circle and see that sine theta equals negative 1 is at 270 degrees. Now, the reason it's 270 is you look up here, it's between 0 and 360. So you got to give your answers between those ones. Now, this left side is the stuff we did before. Okay, sine theta. Is it positive? Yeah. So sine being positive is in quadrant 1 and 2, right? And then we found theta r, or theta related. So sine to negative 1/2 is 30 degrees. So we know the first one is, hey, yeah, 30 degrees. And the second one is 180 minus 30 degrees. So in this question, we're going to have 3 answers, right? 30, 150. I guess, sorry, it was this 30 and 150. It's the same as the theta, and 270. So you got to be careful of that. You got to be really paying attention to how many answers you could have. Okay. Example number 4 is a word problem, and you have to translate the word problem into something that makes sense, in this case, a math equation, right? So a room is 4 meters longer than it is wide. So if we know W is width, for the length there, we just go W plus 4, right? Because that's would be our length. Now, we don't use different variables. We want the same variable, so we're able to do the calculations. And in this case, they tell you that the area of the room is 165 square meters. Well, how do you get area? Well, it's length times width. So in this case, the W is the width, and this W plus 4 is the length. And there we go again, 165. Well, how do we deal with this? Distributive property, right? W times W is our W squared. W times 4 is our 4W. Okay, so then we're getting down here. Well, how do we rearrange this? Well, to get the 165 over to the other side, you subtract by 165. So if you look, now we end up with 0 equals W squared plus 4W minus 165. This is our trinomial that we're going to work with, right? So we have to factor this trinomial. So if you look over here, I was trying to figure out the different factors of 165 to help me with that, to make sure we could figure out where our 1 came from, right? So we find out that this negative in front of the 165 means the signs are different. Factors of 165 are 15 and 11. A, yes. Is that going to work? Are we going to get our 4W here? Yeah, 15 minus 11, or yeah, there we get our 4W. So again, take each side and set them equal to 0. So we have 0 equals W plus 15. Negative 15 meters equal W. Okay, you'll see why I crossed that off in a sec. This one, you move the 11 over to the other side, you get the width equal to 11 meters. Okay, so why can't this first one work? Why can't the width be negative 15 meters? Come on, think about that. Can distance be negative? Can I have negative 15 meters distance? No, it's impossible. So what we refer to this as an extraneous root. So not only are you going to have to do the math now, you're going to have to check to see if your answers are actually regular answers or if they're extraneous roots. So you got to be careful of that. So this one doesn't work because the width cannot be negative 15. So down the bottom here, yeah, our width is 11 and our length is 4 more than that, so our length has to be 15. And if you took 11 times 15, yeah, you get your 165. So you can see the progress here, right? You're going to end up with an equation, and sometimes you have to do some things to get to the trinomial and set it equal to 0. Then you got to factor it. Then you got to solve both sides, and then you got to check your answers, right? There's quite a few things you have to do when you're dealing with word problems.